Alright, so once again, welcome to Pinoy Science Lectures. So once again, this is Bert from Munturin Senior High School. Alright, so to start our lesson for today is all about the heat in phase changes. Let's have here a diagram representation on how water turns to different state of matter. So we have first melting, wherein solid turns to liquid, and then liquid turns to gas, and that is evaporation. So there is also a process wherein the gas turns to solid, and that is deposition. Okay, if you're just going to turn water into solid, that or liquid turns to solid, that is also so-called freezing or solidification. And we have solid turns to gas, that is sublimation. And we have condensation wherein gas turns to liquid. So yung deposition and sublimation, that is a process wherein turning solid, gas to solid, or gas or solid to gas without going into a liquid phase. Okay, so the best example of that is water. Okay. So let's now proceed to the next slide. So let's discuss about the heat in the phase changes wherein the heat transferred or heat is required in order for us to, to do the changes in the phase of the matter. So we have here, heat can be absorbed wherein that is what is so-called endothermic. Yung release naman, tawag naman doon is exothermic. So sa phase changes, so the different process, so minsan we used to absorb and we used to release heat. So in melting, we absorb. Sa freezing, we release heat. Vaporization, we absorb heat. Condensation, we release heat. Sublimation, we absorb heat. And deposition, we release heat. So ito lang, summarize lang to. Okay, so let us now proceed to the heat and cooling curve. So in heat cooling curve, it describes about the transition of a phase. It also describes the how temperature changes as substance heated up. Okay, so on a y-axis, we have the temperature here, and then for the x-axis, we have the heat added. Right, so let's talk about the the temperature as we turn the solid into gas form. So from solid to liquid, we as the temperature increases, we reach the melting point. So water, example of that is water wherein or an ice start to melt when we reach the 0 degrees Celsius. So doon na mag-start mag-melt yun. And then if you're just going to notice also on the graph, yung temperature niya ay dito sa zero. Zero lang siya until we completely turns that into liquid. So zero lang, stable lang yung kanyang temperature. And then after that, so once we completely change that into liquid, so akit na naman yung temperature until we reach the boiling point. So when we say boiling point, temperature at which liquid turns to gas. So yan. From there, 100 degrees Celsius, so water, that is the boiling point of water wherein the water is starting to boil. So nagkakaroon ng mga bubbles doon wherein yung gas nag-start na mag-escape. And then wherein also this is the process where this is the stage wherein the liquid starting to become gas. Okay, now, so if you're just going to notice at this point, yung kanyang temperature ay stable lang, 100 degrees Celsius, until we completely change that into gas. Okay, now, let's talk about the kinetic energy from from the different transition of phases. So sa kanina dun sa baba kung saan yung from negative degree Celsius going to 0 degree, so yung kinetic energy niya nag-increase once we increase the temperature. And then yung potential energy niya stay the same. So when you reach the 0 degree, nag-stable lang yung kanyang temperature, ang mangyayari dyan, yung kinetic energy niya ay stay the same and the potential energy increases. Okay, doon naman tayo sa kung saan yung from 0 nag-turns na into liquid pataas going to the increase of 100 degrees Celsius, yung kanyang kinetic energy nag-increase and then yung potential energy niya ay the same. Now, doon naman tayo we're in 100 degrees Celsius, nag-boiling point na yon ng water. So yung kinetic energy niya ay stay the same, tapos yung potential energy niya ay nag-i-increase. Then after that, kung saan yung liquid turns to vapor, so yung kinetic energy niya increases and the potential energy stay the same. So that's how we describe the kinetic energy and potential energy of the molecules of water. Okay, so let's now proceed to heat in phase changes. Next one, we have the how to calculate the temperature change. So we use this formula wherein Q stands with heat is equal to mass. Tapos yung C na yan, it stands for the heat, specific heat. And then yung triangle, that's delta, T, which is the change in temperature. So we're going to have a different topic about that wherein I'm going to give you a set of problems on how to use that formula. And then we have heat fusion. We use heat fusion, that is the quantity of heat needed, quantity heat needed to completely melt 1 mole of substance once it has reached its melting point. So that is heat fusion. So that's the formula. So heat is equal to mole times heat fuse. Next one is heat of vaporization. We used to follow this kind of formula. So heat vaporization, the quantity of heat needed to completely vaporize 1 mole of substance once it has reached its boiling point. Okay, so the formula is heat is equal to mole times heat vaporization. Okay, so again, we're gonna I'm gonna create another video for that on how to compute the heat vaporization. So let's talk about the vapor. When we say vapor, that is the gaseous state of a substance, and vapor pressure wherein this is the pressure exerted by a vapor in equilibrium with its liquid phase in a closed system. Let's take a look at this what do you call this one, illustration. So we have three figures, and we have the Erlenmeyer class. Okay, so we start to we have water there, the molecules of water, and if you're just going to notice in the letter A figure, that is the start of the evaporations. And then for figure B, that is the evaporation continues, and then the condensation also begins. And then from letter C naman, that is we're in the condensation, the rate of condensation and the rate of evaporation is equal. Okay, so that is vaporization. Okay, let's start with, let's talk about the boiling point. Okay, when we say boiling point, the temperature at which the vapor pressure is equal to the atmospheric pressure. So when the temperature reaches the boiling point of water, the molecules in liquid have enough kinetic energy to escape the gas bubbles. So yung mga gas na yun, those are the gases that is in the water. Usually those are the gases dissolved in water. So kapag tumataas yung temperature, so ayan, yun nga, tawag doon nagbabubble up. So that is the time na nag-escape yung kanyang mga gases. So application yan, let's say for example, pag summer, so yung mga fish ponds, yung bakit mga namamatay, or kunyari, let's say for example, El Nino, bakit namamatay yung mga isda sa mga fish ponds? Kasi yung oxygen level niya ay kumukonte. Why? Kasi yung mga oxygen niya ay nag-escape. Okay, kasi nga because of the increase of temperature. Okay? Alright, so let's now talk about the water. So kanina, sabi ko sa inyo, water is the best example of the kaninang diagram on how this, change that from solid to liquid and then liquid to gas. Okay, so water is made up of, basically that is made up of hydrogen and oxygen. How many atoms of hydrogen? We have two atoms of hydrogen. And that is a polar substance. And the oxygen is covalently bonded to hydrogen. Okay, and most widely used this one as a solvent, and it has a highest specific heat. Okay, and another thing for this one is mas dense siya kapag liquid than solid. Kaya yung solid, kaya di ba yung mga ice, or yung ice, when you are going to put that in water, lumulutang siya kasi less dense siya. Okay, so that is all about the topic about the heat in phases of heat in phase changes. Right, so tomorrow next video siguro as I check yung yung curriculum guide, solubility yata yung susunod. So we need a board kasi may computation yun. So thank you so much for watching. Have a nice day.